All right, there are two cases for absolute value. So I'm just going to review the definition briefly with you. If x is 5, we're saying that the absolute value of 5 would be 5. Same exact number because x is positive. That's the first piece of the definition. The absolute value of negative 5 is also 5, but these numbers are not the same. And in fact, the 5 is the opposite of negative 5, and that's really what the second part of the definition is. If you have a negative number, you have to write the opposite of that negative number down. So keeping that in mind, this two-part definition, you'll recall in our summer packet, we rewrote absolute value without the absolute value sign. Each absolute value has actually two possible cases. One case is where you write the same exact number down. But then you're assuming that what you're writing down, x plus 1 in this case, is greater than or equal to 0, which certainly implies that x is greater than or equal to negative 1. If you write the opposite down, the opposite of x plus 1, you're assuming then that x plus 1 is less than 0, which would imply x is less than negative 1. Similarly, if I have that, there are two cases. 1 minus 3x, the exact same thing that's in the absolute value, but again, I'm thinking that then 1 minus 3x would be greater than or equal to 0, and then solving for the x there, I get x is less than or equal to 1/3. It's the opposite of 1 minus 3x. If 1 minus 3x is less than 0, which would imply that x is greater than 1/3. And I'm literally just solving this inequality to determine those values for x. So you're probably saying, okay, what is she up to? I'm up to trying to solve this kind of inequality. Because of the two absolute values, I need to be able to rewrite the inequality without the absolute value sign, much the same way we did when we solved more simple absolute value inequalities. So we understand that if I look at the absolute value of 1, there are two ways I could write it. I could write x plus 1, or I could write the opposite of x plus 1. But if I write it this way, I'm assuming then that x is greater than or equal to negative 1. And if I decide to use this one, I'm assuming x is less than negative 1. Similarly, if I have the absolute value of 1 minus 3x, I can write 1 minus 3x, but I'm assuming that x is less than or equal to 1/3. Or I could write the opposite, in which case I'm saying x is greater than 1/3. So I want to write the problem so it has no absolute value. Well, let's suppose I want to write absolute value of x plus 1 as x plus 1 versus this. Then what I'm saying to you is that if I decide I want to write x plus 1, I have to then say x is greater than or equal to negative 1. It's the only way I can write that. If I want to write 1 minus 3x for the absolute value of 1 minus 3x, then I am assuming that x is less than or equal to 1/3. So I'm writing x is less than or equal to 1/3. That's the only way I can write this. Now between the absolute values there is a greater than sign, so I'm going to write that in there. I do need to make sure this kind of scenario makes sense. Can I have numbers that are greater than negative 1 and at the same time less than 1/3? The answer is yes. That will mean that my x is really between or equal to negative 1 and 1/3. So when I solve this problem, I got to get numbers between negative 1 and 1/3. If I don't, I have to throw it out. So let's add the 3x, so we get 4x is greater than 0, x is greater than 0. X is greater than 0 is not the solution, because remember, I started with numbers between negative 1 and 1/3. So the actual solution here is x has got to be bigger than 0, but less than or equal to 1/3. So I'm looking for where this solution and this solution overlap, and that's right in here. We call this case number 1. So let's do the same problem, but I'll do case number 2. Let's assume that now I want to write, instead of x plus 1, I want to write negative x plus 1. Then that means I am assuming that x is less than negative 1. So if I'm going to set up another scenario, if I want to write negative x minus 1, then in order to do that, I have to say x must be less than negative 1. Let me separate the problem. If I want to write 1 minus 3x, that's fine, 1 minus 3x. But then I'm saying to you that x has got to be less than or equal to 1/3. So the only way I can write this if I know x is less than negative 1, and the only way I could write 1 minus 3x if I know x is less than or equal to 1/3. Between, again, the absolute values was a greater than sign, so I'm going to put a greater than sign. Is it possible to have numbers that are less than negative 1 and at the same time less than 1/3? The answer is yes. All numbers less than negative 1 are also less than 1/3. So then this is worth solving to me. So I add the 3x, so I get 2x greater than 2. X is greater than 1. Now I look at where I started and I look at what I got for my answer. Can I have numbers bigger than 1 and at the same time less than negative 1? The answer is no. That's not possible. So there is actually no solution from this case. So case number 2 yields no new information. All right, let's look at case number 3. Change my colors for a minute. So case number 3. So you might think, well, let's see if we could write the negative here with the negative there. So we've done the positive x plus 1 with the positive 1 minus 3x. We've done the negative x plus 1 with the positive 1 minus 3x. Could we do a negative with a negative? We can try. So is it possible to have numbers that are less than negative 1 and at the same time bigger than 1/3? So I'm looking at the condition. Can I have numbers less than negative 1, bigger than 1/3? Of course, the answer is no. So I would never write the negative x plus 1 is greater than negative 1 minus 3x because the situation is impossible. It's impossible for me to have these two conditions at the same time. Now there is one other case. I could have numbers that if you look here, I've picked numbers between negative 1 and 1/3, and here I've picked numbers less than negative 1. I could have a case where x is greater than 1/3. So my third case is actually x is greater than 1/3. If x is greater than 1/3, it is automatically greater than negative 1. So that means I am forcing to use the positive version of the absolute value of x plus 1. So I have x plus 1 is greater than, x is greater than 1/3 means I'm now using the negative version of the absolute value of 1 minus 3x. So I have the negative 1 plus 3x. I went ahead and distributed the negative. Solving for x, I get negative 2x is greater than negative 2. Dividing, I get x is less than 1. So notice what I started with. X is greater than 1/3. I got x is less than 1. All right, it is possible to have some numbers bigger than 1/3 and less than 1. Those numbers would actually fit between 1 and 1/3. So my second solution is right there. X is between 1 and 1/3. X is between 0 and 1/3. Putting those two answers together, somebody might say to me, well, then Mrs. Judy, x has to be between 1 and 0, and they would be absolutely correct. So the final solution, if I was to actually write it down, the solution to this problem would actually be x is between 1 and 0. Oops, forgot my less than sign. And that's actually a combination of the two cases. So I'm taking these two situations, saying that would be describing those numbers up there. And that's the answer. Now what I'm hoping is that in class I'll show you a different method to solving this.